Hello friends, welcome to Shiksharthi. In this video, we'll be talking about numbers. So let's start. So at the very outset, since this being the first session for numbers, we'll start off with the classification of numbers because I personally feel that this is going to be really important henceforth when we talk about other videos on numbers. Okay, so when we start off with the classification of numbers, the numbers can be broadly divided into two parts. One is the real part, real numbers, and the other part is known as the non-real part. Please recall that if I have to divide something, I can always divide it like cross or tick. But this division may not be always correct, because there may be a position like a neutral position also, which is equal to. What I intend to convey here is, this may be plus, let's understand that this is plus. Let's understand this is minus, and let us say it is neutral. So when I say that there is something which is not negative, it does not mean that it is positive only. It may be equal to 0 as well. So coming back to the basic discussion, if I say the numbers, the broad classification of numbers is what? Real numbers and non-real numbers. So there are only two possibilities of classification, broad classification. So with the moment I say non-real, it has to be understood as imaginary. Yeah. Going further, real numbers can be further divided into two parts. One is the rational part and the other is the non-rational part. Now, since real numbers can be divided exactly into two parts only, which is why the non-rational part becomes irrational part. Right? First, I'll explain this and thereafter I'll take some examples on this. Further on, when I see the rational numbers may be further divided into two parts. Now, those two parts are rational numbers are either integers or non-integers. Right? But irrational numbers are always non-integers only, and they fall under a special category of non-integers, which this category is different from this non-integer category, which comes under the head of rational numbers. I'll repeat. Rational numbers can be further subdivided into two parts. One part is the integer part and the other part is the non-integer part. Now, when I talk about irrational numbers are non-integers only. But these non-integers are different from the non-integer part of the rational numbers. We'll see. Further on, the integers can be divided into three parts. Now, integers are represented by a capital Z. So, for further discussions, whenever we are taking a capital Z, that means we are talking about integers. So, when I say integers can be broadly divided into three parts, we are basically talking about negative integers, neutral integer which is 0, and then positive integers. Now, positive integers only are known as natural numbers. The denotation of natural numbers is capital N. For further discussions, whenever I use a capital N, wherever, whether I am talking about number system or I am talking about any other thing, and if I say numbers, then we are talking about capital N basically denotes natural numbers. So positive integers are always natural numbers and natural numbers are always positive integers. Please understand it. I am introducing the concept of deductive logic here. Now what am I saying? All A's are B's, and at the same time I am saying all B's are A's. Okay. Now when I combine the neutral integer along with the positive integer, it is known as a whole number, and a whole number is denoted by a W. Another way to understand this is when I say whole numbers, all whole numbers are positive integers? No. Are all positive integers whole numbers? You need to talk about all these things if I'm talking about. So please introduce the element of logic here. It makes the understanding quite comprehensive in nature. This is what I'm trying to suggest. Okay, going further, the natural numbers. Now these natural numbers or whole numbers may be further classified as even numbers or odd numbers. Okay, so capital E is for even numbers and capital O is for odd numbers. Now further going, I'm talking about a further division. So we are talking about a subdivision. So we are talking about even numbers and odd numbers may be either prime or they may be composite. I repeat, even numbers and odd numbers may be either prime or composite. So what I mean to say here is, can I say all even numbers are prime numbers? No. even numbers and odd numbers combined together are prime numbers, and the same thing you will say for composite numbers also. I hope I have made my point loud and clear. Okay, so here we were only talking about integers. Now let us talk about non-integers under the head of rational numbers. So when I am talking about non-integers may be further classified into fractions and decimals. When I say decimals, I am talking about a decimal point. Okay, now when I say a decimal point, if I say this is 2.3, this representation is incorrect. Now this has to be understood as 2.3. Now when I say this is 2.3, this has to be understood as this is 2 plus 0.3, which is nothing but 2 plus 3 by 10. So you will see that decimal points can be converted into fractions. So something which is very important here is under the head of natural numbers are fractions. Right? Okay. So now fractions can be further divided into three parts. Which parts? Proper fractions, ideal fractions and improper fractions. And then we can further divide the fractions or the decimal points into terminating decimals and the recurring decimals. For example, few minutes back I was talking about the non-integer part of the rational numbers is very different from the non-integer part of irrational numbers. This is what I was trying to highlight. So when I am talking about rational numbers, I'll talk about either terminating decimals or I'll talk about recurring decimals, the examples of which are given to you. I'll not be discussing the fractions and decimal points here because I've already done a video on fractions and decimal points. You can refer to that video for a further discussion on fractions, which is non-integers. Okay. Now when I'm talking about irrational numbers and I'm talking about non-integers, I'm basically talking about surds or special kind of non-integers. Now when I say special kind of non-integers, I'm basically referring to pi, or I'm talking about an exponential e. They come with a value. For example, pi is given as 22 by 7 or 3 point something. So when I say these are non-integers, I am basically referring about those integers which are neither terminating nor recurring. Yeah, I hope you understood it. Okay, so now taking few examples. What are real numbers? Real numbers are those numbers which can be represented on a real number line. Now when I am talking about a real number line, I am talking about any kind of a number that can be represented on a number line. So real number that can be represented. Now why this arrow? Now in one of my videos I have already talked about what is the importance of arrow and what is the importance of a dot. For example, if I put a dot here, that means this point is inclusive. But if I put an arrow, that means this point is exclusive. I mean it is not included. So the relevance of here, the arrow here is minus infinity and here it is plus infinity. So you are moving from the negative side to a rather positive side, right? So in between you will be having, let's say, minus 1, you will be having plus 1. So what are these minus 1, plus 1 and zeros? These are integers. So what are integers? Integers are those numbers which are written without a decimal point. For example, if I write merely 2, what is it? It is a positive integer. At the same time, I could have written a negative integer also. And then minus 100, plus 100, 101, minus 101 and so on. These are integers. Non-integers, yes, this is one variety of a non-integer. Can I say this is a terminating decimal? Yes, it is a terminating decimal because it stops. But at the same time, if I would have written 2.3 bar, this becomes a kind of a recurring decimal. Recurring means this has to be understood as this is 2.333 and 3 continues. Right? So we talked about real numbers are those numbers which can be represented on a real number line, and we talked about the importance of arrow, dot and so on. So can I say this is a dot? Yes, this is the point which falls on the way, which is inclusive. At the same time, we talked about integers, we talked about non-integers also. Right? So what are rational numbers? Rational numbers are those numbers which can be written in the form of a numerator upon a denominator, such that the numerator is either a positive, negative or neutral integer. So either it will be minus z or it will be 0, or it will be plus z. I repeat, a rational number is a number which is written in the form of a numerator divided by a denominator such that the numerator is either a negative integer or neutral integer or a positive integer, but the denominator will either be a negative integer or a positive integer only. So if I give you what is 1 by 0, is it a rational number? No, it is not. Right? Because the denominator cannot be a 0. And then when you are talking about fractions, can fraction be written in this format? No. Why can't it be written in this format? Because a fraction is a byproduct of rational numbers. Can I write a fraction under the head of irrational numbers also? Yes, I can. Before I discuss that, let me talk about surds. Okay, so what are surds? So numbers written under the roof of a root are surds. For example, if I write root 2 plus root 2, or I write minus root 2. If you recall my video on quadratic equations, I have talked about rational roots, I have talked about irrational roots. So numbers are very important not only for the chapter on numbers, but they are important for other chapters as well. So it is one of the very important chapters in mathematics. So can I write a fraction as 1 divided by root 2? Yes, I can write down. But if I am writing down this, so it becomes a non-integer only, and this falls under the category of irrational numbers. Why does it fall under the category of irrational numbers? Because it is a form of a surd. Okay. Now there is one more point which is important to be discussed here is, if I am finding out the square root of 4, how much is this? This is plus 2. It can never be equal to minus 2. If you say how, I have already done a video on this. Please refer to one of my videos wherein I have talked about if x square is equal to 4, how is this different from if x is written as root 4. So if I am writing if x square is equal to root 4, then can I write x is equal, if I am writing x square as 4, can I write it as x is equal to root 4? I can always write, but this interpretation may or may not be correct. Please refer to the video on this. So coming back, how much is root 4 plus 2? At the same time, if somebody is asking me to calculate the value of root of minus 4, this will never give me a real number. And what will it give me? It will give me plus 2i. Now what is this I here? The imaginary part. So how are imaginary numbers represented? They are represented as a plus ib, where I is the imaginary part in it. Please understand it like this. This is nothing but x plus iy. You have the x coordinate plus you have the y coordinate, and on the y coordinate itself is the imaginary part which is represented. Right? Okay. At the same time, if I am calculating the cube root of plus 8, how much is this? Plus 2. How much is cube root of 0? 0. How much is cube root of minus 8? Minus 2. Let me draw an analogy here. If I am calculating the square root of plus 4, how much is this? Plus 2. If I am calculating the square root of 0, it is 0. If I am calculating the square root of minus 4, this will give me plus 2i. That means among all these calculations, if I say tick symbolizes real numbers, these are ticks. And if cross symbolizes imaginary numbers, then it is this. Right? I hope I have made my point clear here. So finally, what are rational numbers? Rational numbers are those numbers which are represented in the form of a numerator upon a denominator, such that the numerator is what? An integer, either a positive, negative or neutral integer, but the denominator will always be either a positive integer or a negative integer. What are surds? Surds are those numbers which are written under the roof of a root. Can I have an imaginary surd? You can have various permutation combinations here. I mean, all these discussions that I have done here, this entire discussion that I have done under the head of real numbers, this entire discussion can be done under the head of non-real numbers also, which are imaginary numbers also. For example, I can write that 1 by 2 plus I by 3. So I brought the fractional part here. Can I write down 1 plus I root 2? I can. So I brought the irrational part here. If you think that something interesting has been discussed in this video, please do not forget to like, share and subscribe to our channel. Okay, so until next time we meet, goodbye.